Adrian, can you teach me how to kick a soccer ball?
Yeah, sure. I'm going to teach you the physics behind kicking a soccer ball.
Every object will continue in a state of rest or with constant speed in a straight line unless acted upon by an external, unbalanced, or net force.
In this case, Adrian's foot is the unbalanced force acting upon the soccer ball at rest. This causes the soccer ball at rest to start moving.
When a net force acts on an object, the object accelerates in the direction of the net force.
In this case, the soccer ball accelerates in the direction of Tupac's foot, which is the unbalanced force.
For every action force, there's an equal and opposite reaction force.
In this case, the action force is Adrian's foot hitting the ball, and the reaction force is the ball pushing back on Adrian's foot, although the effect of this force is negligible.
Why didn't it go far enough?
Well, Jalea, there's a little thing I like to call the force of friction. The force of friction acts opposite to the motion or attempted motion. When you kick the soccer ball on top of the grass, the force of friction opposes the continuous standing of the soccer ball.
How do I know? Camera's over here. How do I know how far it will go?
I'm over here, but let me explain.
Projectile motion is a way to describe the motion of a soccer ball after it is kicked. Once it's launched, there is no longer a force acting on the object in the horizontal direction. We know once it is kicked up, it will accelerate downwards due to gravity.
Well, Jalea, in order to find the range, or the displacement in x, which is how far the ball goes, the ball traveled approximately 45 degrees from the horizontal and traveled at approximately 15 meters per second. We calculated this using the shutter speed of the camera and the angle from which the ball was kicked. Using this, I was able to calculate the velocity in x and the velocity in y. Since the angle is 45 degrees, I could use the Pythagorean theorem to calculate the x and y components to the velocity. I know that the force of gravity is 9.8 meters per second up or negative 9.8 meters per second down. The final displacement in y for the ball will be 0 because it's on the ground. With this, I have enough information to solve for time, which is what I did right here. Time came out to be 2.165 seconds. And since time is the same for both the x and y components, I could plug it into my x area. Since I now have time, I could solve for displacement in x, and my displacement in x came up to be 22.964 meters.
So, Jolea, what did you learn today?
I learned that all of Newton's laws affect the movement of a soccer ball. Secondly, I learned that friction will affect the distance of a soccer ball if it's kicked on top of the grass. If the soccer ball is projected, aspects such as angle, velocity, and time will affect its range. I also learned that
Miss Murphy is the best teacher ever.